All right, 5e is now logarithm. So last session you did exponential rules. Now we're going to logarithmic graphs. Last session you did logarithmic rules. So now it's log graphs. Now, I'm assuming by this point, hopefully you can read the transformation. That was from chapter 3. If you can't, you can copy my notes from here. But essentially, you should be able to see dilation, translation. Yeah, and reflection is just when it's negative. So it's all there. What do you need to remember from it though? Log properties. We always know it's now going to be the reverse of exponential. So asymptote's not a horizontal asymptote. It's a vertical asymptote at x equals 0. So you must always label the equation with the asymptote. Number 2 is that it will always have an x-intercept, whereas the exponential would then be the other way. It will have a y-intercept. And then your domain and range is just based on your graph. So we can see that the domain is R+, and the range is all real values. Okay, so basic properties of log graphs. I think the one thing is to know the properties. The other one is seeing the graph in your head. So when you're starting to do the algebra component, you'll understand why you can't do log of a negative number. Because graphically, you can't do log of -1 as an example. It doesn't exist. So if you have the visual in your head, then when you're doing the algebra component, you can also tick off which one does work and which one doesn't. Yeah? All right. So what is 5e about? 5e is just you sketching the transformations that you see. We know that exponentials and logs are inverses of one another, and therefore it is a reflection in the line y equals x. So this is an example of what it looks like. Here's 2 to the x, and here is log base 2 of x. So there's just essentially, if you didn't realize, the coordinates essentially 0, 1 now becomes 1, 0. And that's what we mean by reflection in y equals x. So the transformation is xy becomes yx. Okay? It's just the understanding of chapter 1, exercise 1F. Let's do an example. Now, I've already left these solutions here because I'm assuming you can read the transformation. So here, hopefully you can read the transformation up by 2. This is to the right by 2. Reflection and a dilation of 1/3, not 3. So 1/3 from the y-axis, and it moves to the right by 2. And then this is dilation of factor 2 from the x-axis, and then a reflection in the x-axis as well. That's the skill from chapter 3, and if you're not there yet, then build your skill towards that, being able to read, because then chapter 5 sketching and all that relies on that. So if you struggle with 5e, it's probably because your transformations for chapter 3 needed brushing up on, okay, or mastery. So there's your determine the transformation sequence. Then determine the asymptote. Well, once you know how much you're moving up, down, left, right, well, we know the log graph only had a vertical asymptote. So as long as you move left and right, that's the only time it affects the asymptote. So here it says translate 2 to the right. Therefore, the asymptote has moved 2 to the right. Okay, so answering part A and part B. Part B must mean that x is now moved to the right, so the asymptote is at x equals 2. Okay? And then lastly, C, sketch the graph. Now, when you sketch the graph, you need to label the asymptote. You need to label the x-intercept and y-intercept. I put the solutions for the x-intercept in case your algebra is not yet strong, so you can copy that step there. But same thing, you let y equal to 0, -2 on both sides, divide both sides by -2, so that's how I got the 1. And then getting rid of log base 2 is inverse of log. Inverse of log is exponential. So it's 2 to the power of log base 2 on the right, and 2 to the power of 1 on the left. So that's mean you're doing exponential. So 2 to the power of 1 is 2, and 2 to the power of log 2 cancels out, and you end up with 6 minus 3x. Okay, and then from here it's just linear. Solve it, and you should get x equals 4 on 3. The other one I'm missing, I haven't yet calculated y-intercept. So let's see if you can do this bit now. So y-intercept is when y is equal to -2 log base 2 of 6 minus 3 times 0, because x is 0, plus 2. That gives you negative 2 log base 2 of 6 plus 2. And there's really not much else you can do there. I mean, because this is really saying 2 to the power of what gives you 6. Well, we don't know that. So therefore, you can leave your answer as your y-intercept is negative 2 log 2 of 6 plus 2, which I've labeled over here. Okay. And that's pretty much what you see there. Example 1 is 5e. Okay, so 5e is very similar to all the other chapter 4 stuff. 4g, 4h, for example, is just applying transformation to your graphs. Okay? So in order to do this, you need to know transformations well, and you need to know the properties of your function. So log and exponential. The last one is what I thought was interesting. I'm going to get you guys to read it. You guys might have done this from the exercise already, so if you've done it, fantastic. But this one I left blank because I wanted you to think about it. How do I convert through transformation y equals 3 to the x, and I want it to become y equals e to the x? So I want to know what type of transformation. Is it translation, dilation, reflection? How do we do this? Those who have done chapter 4 and submitted, have you guys done this one? Anyone have a clue on what they would do? I'll give you a hint. Bases are different. You're trying to convert 3 to a base e. Can you rewrite 3 to the x in some other way with a base e, but it hasn't changed the original equation? So if you can do that, then you can do a comparison, and hence you can read transformation. So I'll give you 1 minute. Have a think. How do I change base 3?
But is it a dilation?
Is it? Let's give you a minute.
It is 3 on A. No, E is like open. I thought it was dilation.
In 5, 4, 3, 2, 1. For those who weren't sure what to do, here it is. Start off with a base E, because that's what you need. But somehow the e's have to cancel out. And the only way that e's are going to cancel out, if that's an exponential e, then e has to have a power of a log base e. That's the only way it's going to cancel out. True? So I'm going to write here log base e, which these are inverses. They're going to cancel out. And what I need left over is 3 to the x. That's how technically this will cancel out. This expression is exactly the same as the top line. But you can rewrite this expression now. That becomes y equals e. And remember rule number 3. Rule number 3 says you can bring this power to the front, or you could bring it over there. It just means timesing each other. And that now gives you log base e of 3 multiplied to x. So now if I take that equation and I say maps to y equals e to the x, and I'm going to put the dash on these ones so you can see how you'd figure out the transformation. See, they both have a base e, they both have an x, so it's e to the x, and that's e to the x. Clearly, this must be dilation, because I'm taking log base e of 3, which is some value, times by x. So, let's work out the transformation. How do we do it? Again, remember, this is x dash, so if you're doing the mapping, you would say it's log base e of 3, this is mapping notation, is equal to x dash, this is 3e, if you've done exercise 3e, whilst the other one is y dash is equal to y. So what's my transformation? X, y coordinates becomes, whatever x dash is y dash. Well, it turns out x dash was just log e of 3 multiplied to x, original x, and y dash was just equal to original y. So if you had to read this now, dilation of factor what? I confused you guys? No? If it helps, what if I change this to a 2? See, if I said 2xy, that's my transformation, you would have said dilation of factor 2 from the y-axis. All I've done is now wrote log e of 3. We just don't know what that number is. So it's dilation of factor log e 3 from y-axis. So it just means I had to do a compression of this graph to make it e to the x. Okay, so that example there is a bit tricky. Yep.
Well, why isn't the original function? Actually, I don't even know how to phrase my question.
No, I know what you're thinking. So often the common error that students think about is you guys are thinking this way. You're thinking how to move from e to the x to e to the log e of 3x. So a lot of students will think this should be a dilation of factor 1 on log e 3. That's the common thing that most students are thinking about. And that's why in exercise 3e, when you're doing they're finding the sequence of transformation, the mapping notation shows you have to find x dash y dash, and that's where some students get this feeling like they need to rearrange things. You don't. If you've already got x dash, you have x dash, that is the transformation.
Function like mapping, that is a dilation of 1 over.
If it was going from here to here.
Yeah.
Yes. So then it will be a dilation of factor 1 on log e3.
Oh,
but I mean, that's right. And that's the common thing that students feel because they're more comfortable seeing that. They can visualize that. This one knows. So they're starting in their mind from here, going there. And you're correct, it is 1/3. But because we're going from that to this, it's the other way around. Yeah. Okay. And that's why the mapping notation fixes that bit. So when examiners do complex to complex, if you do the mapping notation, you do less mistakes in dilation. But yeah, I thought that was a good one. So that's exercise 5e question 6. If you have a look at it, there's probably another one similar to that one. You can try that one from 5e. But let's now try 5f. And 5f is nothing more than just determining equations, which you've already done previously. In chapter 1, chapter 3, chapter 4, you've done this. So they're all similar. I've got the answers for example 1. Finding B, that's a vertical translation. So we can see asymptote at 4. So therefore, it had to be B, had to be plus 4. And then A, which is a dilation, sub in 0, 2. So if you sub in 0, 2, you got 0 and then 2, and you can solve for A. And then A should end up being -2. So that type of question is very similar to all the other chapters you've done. Chapter 1, Chapter 2, Chapter 3, Chapter 4. Maybe not Chapter 2, but Chapter 1, 3, and 4 definitely would have had exercise determining an equation. So hopefully by this point that will feel somewhat familiar. It just means you have to be able to read properties of a log graph. All right. However, this one, let's do this together just in case you weren't really comfortable with reading log graphs. So we'll do this one together. I'm going to pause the video. I'm going to give you, how long? This should take you maybe 3 minutes or less. 3 minutes or less to solve for N and B. I'm going to pause the video. So answers. Starting off with the asymptote, that's the first property. The only way a log graph has an asymptote at x equals -4 is you have to move it left or right. In this case, at -4, you have to move left. The only way to move left, that means B has to be +4. Hands up if you at least found B. Good. Okay, so that's reading transformations. And then the next bit, there's only one letter left. You need a coordinate. We've given you -12, -24. So a simple substitution to then solve. And then from here, it's about algebra. So stuff that you did last session with logs and log rules. I just subbed it in, so negative 12 for x and y is negative 24. I added 8 on both sides, so hence I got negative 16. And then inside the brackets, negative 12 plus 4 is negative 8, so negative 8n. But then divide both sides by negative 4, I get a positive 4. And then from this step, depending on how your logs were from last year, again, inverse of log base 2 is exponential base 2. And what that just basically means is I'm going to do base 2 to the power of the right and base 2 to the power of the left. So I end up with 2 to the power of 4, and 2 to the power of log base 2 cancels out. So that's why I end up with negative 8n. 2 to the power of 4, 16, divided by negative 8 is negative 2, and you get n equals negative 2. Which makes sense, because there's a reflection in the graph if you look at the shape of the graph. So that's another way to determine it. Can I get a show of hands who got both n and b correct? Okay, cool. So if you didn't get it correct, it's probably just to do with the algebra, which goes back to the last exercise, not 5e, but 5d, I think it was, or 5c. 5d to practice. All right, and last one, I'm going to leave the solutions here. I'm going to pause it so that you can check your answers, but it's a simultaneous equation. In order to do that, again, it's all about 5d, just knowing how to work with logarithmic simultaneous equations. Okay, so I'm going to pause the video there.